Well, hello and welcome. So today we are continuing on the network surface script with a small challenge of changing the script such that our layout of our triangles um, scales automatically. Because currently the way they're scaling is depending on this step number count, which means that if we were to change the number of triangles that we have in our script, then um, the triangles become further and further spaced apart, which is not desirable. Because even though they actually take up the same amount of space as a material, um, so we want them to move closer together. So the way to think through the problem is to imagine that the area is fixed. It's still the same amount of triangles. So we want the paper not to scale, but the distance between them to scale proportionally. So what that tells me is that we're probably going to use this V count. So let me just make a relay to grab that number. And then we go down here to where we have set up our grid. So this is our grid of points. So that's point in the X and Y direction. And this is the distance between the points, because we're using a series component. So this is the step count, which is the steps in between each, and the count is coming from our division up here. So we have 5 in each direction, which makes sense. Now what we want to do is we want to have a fixed dimension size, and I'm just gonna guess here. So Rhino is in millimeters, and it's about 300, 400 millimeters or so that way. Let's just take 400. So that's the extent of our paper. And we want the spacing between each of the triangles to be even. So what that means is that we can divide our paper by the number of triangles that we have. And the number of triangles in each direction is this one here. This is the relay that I took from up here. It's not always the best way of working with relays, but I do also like it sometimes because you can control how the wires go a bit more. So if you want to have a bit of a kink, then you can do that. But yeah, so now we have a division, and that is going to be the distance between each of our triangles. So now nothing much changed. Now this slider is disconnected, but if we then go up here and change our V count, what we can see is that it's almost as if they're fixed. There's a maximum dimension to them, to the size of the space they take up, and what changes is the panels themselves. Well, and the distance between them. Now we're quite lucky that, well, they're almost not touching. There's a bit of overlap, and that's, I mean, this is a fairly imperfect technique, but it is very good for sort of rough. I mean, what you can do is that you can either increase your paper size to be, say, 500 by 500 squared, and that would make sure none of the triangles are actually touching. And as you can see, these are the other half of the triangles that we haven't yet scaled. So that's why they're still spaced out. In terms of making them more organized and efficient for cutting, we're not going to go into that. That's called nesting, which is another interesting topic of its own. But yeah, this is a very simple way of doing that. I mean, what we can do, let's say we want to get a bit more advanced and act as if this is like real A3 paper. So we can copy this down here. That's using dragging and then pressing Alt, the Alt key. We'll do that. So let's say instead we take that one in there. So now we actually have two different ones. So we can change the direction. So let's say that's 320. I think if we assume that our triangles are a bit taller than maybe and less wide, then maybe we swap those two. Then you could imagine that's actually, say, not quite the right size, but that's a bit bigger than an A3. But that's how you could have them scaled in two different dimensions, which works a bit better with these triangles because they are a bit non-unilateral. So that's all for now. I'll keep this short.